Hello everyone, my name is Ellen Webmore. Thanks for joining our final show and tell today, which is about supporting a robust delivery of net zero. Next slide, please. So this grouping of projects, just to do a quick intro, this grouping of projects are centered around improving energy system robustness. So heading forward into net zero, we'll have a lot of variable types of energy on the system and also an increasing likelihood of the likes of weather events. So we want a resilient system that is built quickly to respond to shocks, but also helps us to deliver the carbon savings we need to meet our net zero targets. So today you'll be hearing from several projects. So I'll just draw out sort of the format that the show and tells will follow today. So presentations are 15 minutes followed by a 5-minute Q&A. So please do type your questions into the Q&A box and our presenters will be able to answer those questions for you in the Q&A. We'll also have a 15-minute break halfway through the session. So yeah, we'll get underway now with Secure and yeah.
Okay, I'll begin. Good afternoon, everybody. I'm Jonathan Powell. I'm an Innovation Project Manager at SSEN Transmission. Could you turn to the next slide, please? Next one. Okay, so this project involves 4 partners, including ourselves. The other partners are Carbon Trust, who have carried out a commercial and market review with HVDC cables and XLP LE insulation, which I'll say a little bit more about. A key element of which was stakeholder engagement, which was really instrumental to the work that they were doing. There's the Digital Catapult, who identified SSENT's priorities for a digital supply chain tool set and defined the key features and a potential architecture for that tool set, which we would develop in a future project. And finally, and by no means least, a subcontractor to SSEN was University of Edinburgh, who carried out a technical review of HVDC cables and XLPE, complementing the work of the Carbon Trust. So the problem we face is really is not necessarily a bad problem, but it's the unprecedented uptake of clean energy such as onshore and offshore wind and the journey towards net zero. And this is really creating a large impact and challenge to supply chains. So looking ahead, demand is only going to grow, which places a significant risk on the industry not meeting the government's green targets. And this is not just a problem for our industry alone. And given the supply chain itself is very extensive within the business, the Secure project decided to focus on one key product, which is HVDC cables, which are essential to HVDC projects, such as a Shetland link to the mainland, which is an image taken on the slide there. One of the main components of the HVDC cables is the insulation material, which is the cross-linked polyethylene, so they set XLPE, which is high risk given there's only one major supplier in Europe, and that's Borealis. And all of these factors, I think, really illustrate there's a critical need to de-risk the supply chain and have greater visibility for any future issues. Next slide.
So I'm Gavin Scott. I work in procurement at SSEN. So from the problem Jonathan just identified in the previous slide, along with our partners, we looked at developing a digital supply chain hub based on the component of an HVDC cable as the test case. The digital supply chain hub looked at various options or gadgets which would ultimately support the efficient rollout of new infrastructure projects by giving greater visibility and knowledge of the HVDC cable supply chain. The benefits of the digital supply chain hub would give a greater supply chain resilience and strategic insight into downstream supply chain, potential introduction of new or more sub-suppliers, offering real alternatives to ensure a more resilient and efficient supply chain, and potentially quicker delivery of renewable connections. While the problem initially focused on cross-linked polyethylene in the HVDC market, it became evident that the solutions or gadgets we were exploring could be transferable to other infrastructure markets. Next slide.
All right, around the ways of working as partners. Through this discovery, they were collaborative, iterative, user-centered, united under a vision, and impact-driven. We made use of Agile to integrate learning, changes, and quality in our work. And we made use of design thinking to really drill down on the challenge, identify the shared needs, problem statements, and solution opportunities. Throughout our work, we also check how it aligned with SSEN transmission drivers, initial requirements, expected benefit, and impact on the robust delivery of net zero. Hence, the focus of our work was understanding the market, the supply chain challenge, and really unveiling the hidden opportunities that met the needs. We had Carbon Trust leading with unmatched research, the overview of HVDC and XLP market and stakeholder engagement, and Digital Catapult bringing the best cross-industry supply chain knowledge and exploring the digital supply chain challenge and where advanced technologies could disrupt. And of course, we have SSEN Transmission closely providing their best industry knowledge and learning of what was valuable. Our university team members also bring deeply specialized knowledge that allows us also to ground us. Next slide, please.
Thanks, Nastasia. So yeah, I'm James from the Carbon Trust. So the Carbon Trust in this project, we had two main roles. So the one on this slide is we conducted some we looked at the case study. So looking at the particular case study of HVDC cables and XLPE, we looked at the market. So we started off looking at HVDC cables. We looked at the demand for HVDC cables and XLPE and how that's going to grow over time. We also mapped the supply chain. So this small picture on the bottom left of this slide, this shows you the map of the supply chain that we created. So we looked at the roles, the different roles, all the way through to from the raw materials, all the way through to the end users, and all the way through to decommissioning, and the major actors. We identified all the major actors in this supply chain. And also we looked at the interdependencies, the complex interdependencies between these different roles in the supply chain. And we also looked at the commercial and the regulatory environment. And of course, the University of Edinburgh helped us here, looking at the the technical details associated with XLPE and alternatives that could be used for that purpose of the installation of the HVDC cables. Next slide, please. The other element of the work that the Carbon Trust conducted was stakeholder engagement. So this is just a blow up of the stakeholder map that we created. And what we did is we spoke to part of the supply chain. So we decided to focus on in the discovery phase, we just focused on the TOs, the transmission system operators in the EU and the UK. And our findings were that we asked the TOs about their procurement approach and strategy, about the challenges that they face in procurement, and about the digital tools that they currently use. And all this went on to inform the hub or the gadget that the Digital Catapult, the Digital Catapult are developing. So if we were to continue this into the alpha phase, what we'd need to do is to talk to the stakeholders in the other elements of the supply chain. Okay, next slide, please.
Hi, everyone. I'm Olivia, and I'm a member of the HVDC cables team in SSE. We initially identified the problem, which is that we have a single supplier of XLP material for all European cable manufacturers, and we have considered the following to see how we can de-risk the problem. Sponsor the new cable using an alternative supply. Another aspect would be the qualification of an alternative XLP supply to demonstrate its long-term performance and reducing the supply chain risk by a digital or material solution. For the digital solution, Digital Catapult took on the task to develop an innovative digital supply chain solution. This would be used to monitor the cable raw material and thus increasing visibility by a supply chain risk management tool. This could introduce more suppliers into the market, which may offer alternative options. For the material solution, the University of Edinburgh is looking into it by considering innovative alternatives to XLP, and existing market alternatives are assessed for stability following the market disruption. Next slide, please.
All right. Obviously, the digital solutions that we explore, thanks to the work that we did with Carbon Trust, it allows us to identify the challenge and define it with SSEN transmission, make sure that within it, we identify the shared needs and the key requirements, and then against it, map what were the potential opportunities and solutions that could help. Now, Peter is going to introduce you to those solutions and gadgets.
Next slide, please. So my name is Peter Carney from Digital Catapult. A word on gadgets. So just to say, these gadgets are built on the expertise of SSEN, the suppliers that we spoke to, experts within Digital Catapult have expertise in supply chain, and of course, other industry, relevant industries. It was also, of course, based on the output of the Carbon Trust. A word on the gadgets. So basically, we use this term to define a block of capability that solves a specific user need in this constrained resource supply chain space. It is, of course, important to remember that this is not just applicable to XLPE, but any constrained requirement that the energy industry may have. The term gadget does not aim to define nor limit the size and complexity, and some of these gadgets are significant and complicated. But for each gadget, we wanted to define the following attributes. So what is it for? What does it do? Who is it for? What these users are saying, what these users are thinking, what does it do for them? Also known as jobs to be done. We've defined 10 high-level requirements for each of these gadgets, business value drivers, and potential candidate technologies. All of this is in exquisite detail in the report, which can be made available via the project sponsor. Next slide, please. So 6 gadgets were devised. I'm going to talk about 3 of them in a bit more detail, but the other ones are shown in the slide deck, should you wish to look at them later. The first primary one, if you like, is called the supply chain visualizer. This gives all of the users in the supply chain, SSEN, also their partners, their suppliers, a real-time visibility of exactly what's happening to critical components within that supply chain, where they are, what materials will go into those components, what the machine is doing at the time of manufacture, QA, processes, delivery times, and that sort of thing. You can see there's quotes from various stakeholders we spoke to. So the project manager really wants to know what's happening in the supply chain. So if there are any delays, they can actually do something about it in a timely fashion. The key features of this gadget are dashboarding, inventory tracking, production schedules, capability, and delivery tracking. The second highest priority gadget was called the Supply Insights Checker and Onboarder. So one thing that's needed in this industry is more suppliers of these materials. And a lot of that onboarding is a very manual process at the moment. Suppliers don't quite know what they're going to have to do to comply to the requirements of the energy sector. They don't necessarily know what opportunities lie ahead of them. Conversely, the energy sector need to make sure they onboard suppliers who are able to trade in the UK, have all the right credentials, quality assurance. And so this is what this gadget's all about. It's about connecting suppliers to the opportunity and to the consumers. The main features of this feature are supply registration, order, project specification submission, due diligence, and supplier risk assessment. Next slide, please. The third gadget that I'll talk about in a little bit of detail here is what we call the consolidated order book. It was clear for many of the stakeholders that there isn't this common vision of what even all of the UK's requirements are going to be, let alone Europe, let alone the world. So there's absolutely a requirement for a sort of common order book that all transmission suppliers in the UK or energy providers or that sort of thing can understand what the demand is, submit their demand, such that all players, so suppliers who may wish to set up business in the UK, existing ones, and also potentially government organizations can understand in a consolidated form what the entire order is going to look like for the next sort of 5 to 10 years or so. The key features of this are visualization, data representation, forecasting, predictive analysis, data segregation, and of course, security. The other gadgets, which I won't go through in detail now, but are shown here for completeness, are the standards parts picker. Next slide, please. Digital QA test and audit gadget, and risk manager gadget. So as I said, these are available in the report if you would like to know more. I think that's the end of my slide. So next slide, please.
So the potential benefits, kind of broken this up into 3, but The supplier demand, through understanding the demand on the supply chain, it gives the buyer real insight into their project delivery schedule and the wider market, and can help the buying organisation understand where they fit into the supply chain schedules, giving greater clarity on real delivery timescales. The supplier capacity, by having real-time visibility into component parts, it gives the opportunity to see real-time production schedules, processes, and delivery times. Understanding any blockers gives new entrants the insight of market needs and the potential to move to the market quicker and give alternatives to the supply chain. And it proactively maps the supply chain and allows the market to be ahead of any potential disruptions. And in the categorization, having a core database of standard products from a range of suppliers allows consistency across the market and identifies deviations from any of those standard specifications. A digital audit trail would also be part of that, and it would show any core component parts and would allow a digital quality assurance on these parts to ensure compliance. All these potential benefits should equate to an enhanced operational efficiency by engaging the right supplier at the right time, reduce lead times by knowing demand across the marketplace, and mitigate any risks and enhance resilience. Next slide.
All right, so given the learnings that this project provided around efficiencies and how we could secure and make more robust those key component requirements supply chain being discussed here, the case of the HVDC cables, right, to enhance the delivery, we foresee that some of the key activities that in the future should be considered are: first, provide further market research and wider supply chain stakeholder engagement. Second, the development and experimentation around the high priority blocks of capabilities or gadgets detected and the technologies associated. And finally, an in-depth exploration of those real commercialization options that we could explore. Next slide, please.
Well, thanks, Nastasia. Sorry. So what next? At this point, we've decided to defer an offer application in the next round, which would be next month. And we haven't taken this decision lightly. We've had various reviews internally, and the feeling at the moment within SSENT is the further discussions are required within the key teams to mature the requirements for any offer application. So what we certainly don't want to do is put something in that's rushed and not fully considered. So the plan moving forward is to mature the project definition. And between now and then the next round, which we would anticipate would be a similar time to next year, and put in an application at that point in time. And so in the meantime, we've decided as a group of partners to have a regular catch-up, a monthly catch-up, just to share developments and kind of keep things ticking over, in preparation for that. So that concludes our presentation. So we're happy to take any questions now. Thank you.
Waiting for some questions to come in. Right. No questions. Oh, here we go. Would you consider adding a capability to allow performance data to be fed back into the system?
Something you could pick up, Peter, maybe being, from a tool perspective, gadget tool.
So could you repeat the question? Just slightly broke up for me. Say again, what was the question?
Would you consider adding capability to allow performance data to be fed back into the system?
Oh yes, absolutely. So one of the ideas, one of the actual features of a gadget was to sort of allow digital twinning, if you like. So one of the things that is often apparent in the sort of supply chain is that the supplier of a given component, once they've sold it, have no idea how it's used in market and how it lasts, how it's serviced. And one of the key benefits of the reason that suppliers might want to play in this game is to get insights as to how their equipment is being used actually in market. So 100% absolutely, we'd love to take sort of digital twin it, collect information both in terms of maintenance, support, how it's installed, and then feed that back and bind that to the record of the particular given item. So yes, indeed.
Great. I don't think there are any additional questions, but I'll remind the audience that that Q&A function is open for a little bit once we're into the next presentation. So if our next presenters are ready, we'll move on.
Hi, yes, good afternoon. So I'm Helen Dugdale, Hydrogen Innovation Engineer at National Gas Transmission and Project Lead for this SIF Discovery Project, Supply Chain Resilience in the Transition, which has been a partnership between ourselves, NGT and Insider Pro. Next slide, please. So to begin with, I'll just explain a little bit around the background to the project, which essentially is supporting Project Union and NGT's aims to transition the existing natural gas network to a hydrogen carrying network. And Project Union is the repurposing of about 2,000 kilometres of the national transmission system in a phased approach in line with the government's cluster prioritisation. And it's this which provides the backdrop really to this whole project. And so under natural gas, we currently have a very mature, well-established supply chain, which this move to hydrogen puts at risk. And the factors around that include an increased global demand for assets. As all gas networks globally transition to hydrogen, the UK is not doing this on its own. The volatile nature of the current global market for materials and goods, which doesn't appear to settling down anytime soon. They've got a potential for long lead time for assets, which could be really problematic. And also that's related to the potential for higher than forecast costs in order to secure these assets. So with our partners at Insider Pro, we've been working to better understand these risks and mitigate them. So next slide, please. So just as a quick overview to the project, before I hand over to Insider Pro, we started off with a supply chain mapping exercise, which helped us identify the themes of concerns within our supply chain. This was then followed by engagement activities with current and potential supply chain to identify the risks that we're going to be facing during the energy transition. We then used Project Union as a test case to identify and test the applicability of some of the solutions recommendations we were coming up with and provide a forward route into Alpha. So when I pass over to Jeremy, he'll go through the outcomes in a little bit more detail.
Okay, thanks, Han. Next slide, thank you. Jeremy Bowley, I'm Managing Director of Insider Pro, so it's my team that works alongside Helen at National Gas on this. A bit of context, I think, here is really helpful. We are setting out, putting hydrogen into the gas network. We haven't done a lot of work on the gas network in a very, very long time. We know what we need to do. We need to design a new way of operating. We're not quite sure what that looks like, but there's a lot of work to do on that. We do know we need to install hydrogen-ready assets. So we know those assets are somewhat different from what we've currently got, similar in nature, but different in detail. We know we've got to change pipelines, and we know we've got to upgrade a lot of the kit, compressor stations, etc., along the way to work with hydrogen. That's an awful lot to do. In simple terms, that represents a somewhere between 5 and 10x increase on the work that we need to do on the network over what we would normally do in a year, just maintaining it and sort of managing upgrades. So it's an enormous uplift in terms of the scale of the challenge for National Gas. We've then got to do that against the context of all the stuff that you guys will be talking about today, and that we know about the transition to a more sustainable world that we live in. So within, taking Western Europe as an example, we know that everybody else, all the other European countries, are going to do this at the same time. So we will not be the only people working on hydrogen. We know that there's got an awful lot of work around rail, smart cities, nuclear energy, electricity, all of those other things will change at the same time. And fundamentally, they pull on very, very similar, adjacent, or in sometimes the same supply chain. So for example, we need to do an awful lot of contracting work, sometimes digging holes in the ground, installing plant and equipment, all of those sorts of things, which fall back on a supply contractor network, which will be very, very similar to that used by all of those other places. So it's not just a lot of work to do. It's a lot of work to do in an environment where the suppliers are going to be very, very, very busy doing all these sorts of other things. So I think it's quite a useful context setter to understand that it's a huge uplift and it's happening at the same time as everything else. So that puts the industry and the supplier base under an awful lot of pressure to get things done. If we go to the next slide. So that sets a very challenging background. Here's the good news. The decisions that the organisations make, such as National Gas in this context, we've got an awful lot of agency in managing those risks. So the decisions that we make now in planning for and transitioning into doing this determine how high the bar for risk is on both cost, quality, and time. So if we get this right, then the good news will be we'll deliver a well-priced transition. If we get this wrong, it could get very expensive and take a very long time. So the stakes are pretty high. The diagram there, if you think about going through the clock from sort of 12, 1, 2, 3, and then back round to sort of 12 again, so it gives you a sense of, where we've got a sense of control. What this, I think, proves, and our process proves by talking to a lot of the suppliers and also a lot of the internal team, is that there's a serious focus on what we need to do internally within the organisation and how we work with suppliers. The risks that exist on an external perspective, all the other things that might happen around planning and funding and all those sorts of things, we're not always in control of those, but we are in control of how we go about this and how well we plan for this. So I think it comes back to say, there's a really good chance of offsetting and mitigating some of these risks if we fall back and think about how we do this as an industry, how we work together with people, how we set suppliers up to succeed, as opposed to compete in a very, very, very challenging environment. So that, in the report goes into quite a bit of detail over what those risks are and what they might mean. But I see this as a good news slide, which is there is definitely opportunities to do better, but doing nothing looks a very expensive and a very long road to a transition. We go to the next slide. Effectively, where are we now is this sort of piece on the left-hand side. So we don't have much competition within our contractor supply chain. That's probably one of our biggest areas of risk. Whilst we've got to go and buy lots of bits of kit and upgrade and overhaul lots of bits of kit from that sits on the network, we're probably going to buy those from people who already supply that. We know that overhauling is a lot cheaper, so we are going to be developing the existing relationships as opposed to bringing in lots of new suppliers. It's simply probably not viable given the kit that we need to bring in. There is, and this is well documented, absolutely not enough workforce to deliver this work. So even if it was just the gas network that we had to do, and that context fell away, and we didn't need to do all the things around nuclear in the country and all the other bits of the energy industry, we definitely still don't have enough workforce. So there's a significant long-term risk there that we need to address. We know bringing in new suppliers doesn't help us there because they fundamentally pull on the same workforce, the same subcontractors and the same groups of people, and that group of people is not growing, but the workload is going up 5 to 10x. The way that we go about this, generally speaking, in traditional sense, the legacy terms of engagement really aren't that appealing from a new supplier perspective. What we know is that when suppliers enter a marketplace, that needs to stack up from an investment perspective. That needs to make sense for their business to do it. There are quite high barriers to entry, particularly on the contracting side, given that the works are quite big and quite expensive in nature. The way we currently do that needs to be improved. I think that's probably an industry level thing as opposed to a national gas level thing. There's been lots of government content on this. There's still lots and lots of work to do in that space to encourage people in. And even if we were to achieve making that better, there is such a high bar and such a big challenge that really represents quite a challenging barrier. As I said before, internal process policies, habits, toolkit, the way we operate. The last presentation I thought was quite insightful on this sort of stuff. Set up in the right sort of way, there's really good opportunities to offset this. But at the moment, this sort of old way of doing things won't work in a 10x environment with workload. So that needs to be addressed and needs to be looked at. And we know that the traditional way of working, the sort of project tendering approach that we've seen over many, many years, Doesn't work as well as long-term collaboration. We know it's expensive for suppliers. We know it's expensive for internal teams. We know it's clunky. We know that there's a risk with collaboration and that needs to be squared, because we will very much need to collaborate with the supply chain to stand a good chance of delivering this. So we think of it really as being 4 deliverables, 4 things that we must achieve to make sure that we've got a functioning and effective market. Commitment to enabling market at all stages. So all bits of the build, all bits of the process of converting the network. We need to make sure we've got effective competition. And that means that we need to find the things that get in the way and remove those barriers to effective competition. We need to be exposed to as few instances of very little choice of supply chain or very little choice of ways of doing things as quickly as possible. And that needs to be thought through really, really well and built off a collaborative fair basis. In terms of engagement, need to be investable. We know through our work, we looked at the finances of various different organizations, construction organizations, contracting organizations, and a number of the other bits of the supply chain, including a number of sort of interesting SMEs, just don't have the cash to support a 10x increase in work, a 5x increase in work, or even sometimes a 2x increase in work. We need to really rethink that and think about how we engage with those suppliers and make sure that it makes sense for them to grow their business with us and make sure that we've got the supply chain in place. And there's a lot of work to do around that. As I said before, at a sort of sector level, we don't have the workforce. There needs to be work done outside of a relationship with one contractor or one supplier to make sure that we've got enough people coming into the workforce. And that requires some investment and some planning and some coordination up front, and that must happen, or we will literally be short of boots on the ground to get the work done. And the final bit really is really important one and often missed is we're going to probably have to think about how we operate with a regulator in order to make all of those things I've just talked about happen. So the traditional way of tendering, the traditional way of going about procurement, sort of the framework that the procurement team at National Gas has to work within constrains doing a lot of really, really sensible things. So I think there's a reset of that process to make sure that the regulator gets out of it what it needs to see in terms of money well spent and value. But equally, that doesn't become a barrier to achieving the things that we've just talked through. Next slide, please. So in terms of an alpha phase, lots of work to do. We picked out a number of areas here that we felt were really worth looking at. And I'll just quickly go around the clock on that. So refreshing our design and procurement and standards approach. So how we go about procuring materials, how we go about specifying those, and how we go about giving ourselves a lot of choice. A lot of our upstream decision-making there can unlock competition, it can unlock choices, it can unlock kit availability. So there's a real piece to look at that and think through how we go about minimizing the amount of work we have to do and maximizing the choice that we have. As I've talked about, the industry piece on workforce development, that needs to happen. There's some good work going on at the moment, but there's some more coordination needed, and some work that goes cross suppliers. Suppliers and contractors felt very positive about doing that sort of work. So there's an open audience there because it represents as much of a problem for them as it does for the network operators themselves. Crossing the bridge on program procurement and project procurement, some of that happens now, not enough to support 5 to 10x increase in work. And it creates some technical challenges around how you prove value. So there's a whole piece that needs to be developed around that. For main works contractors, that's what the NWC refers to, making sure that we don't trip over ourselves by being too risk averse in our relationships with suppliers. It needs to remain something that makes sense for them, not an open checkbook, but equally something that they can put cash into in a context where they are choosing customers and choosing industries to support. There will be more work than there will be supply chain. We know that. And so it's a question of becoming a choice customer in that environment. And the final two really come back to some real business basics, which is really around cash flow. This is a drum that's been banged long and hard by many people, and I think not a problem that industry has yet solved, which is how do we support both our contractors and the subcontractors with reliable cash flow. So working through that and figuring out how we make sure that these businesses have cash flow and the funding to operate. In any business, you have to send the cash out to do the work, to earn the money, to then receive the cash. And that process at the moment is sort of okay for the sort of levels of work that we've got. But again, if we go for multiples, it creates a huge working capital requirement for the suppliers, both at a subcontractor and a main contractor level. It certainly shuts out some good SMEs potentially, and puts even some of our big contractors under quite a lot of pressure. These are tight markets. It's a challenging place to work in the best of times. So this needs some particular consideration of how this works and how this knits together. I think I'm handing back to Helen now.
Thank you. Yeah, next slide, please. Thank you. So having taken all of those outputs and potential recommendations for an alpha project, we've kind of pulled all that together and decided we've got a bit more agency to tackle the internal risks and things focused around that. And so decided that should be kind of the focus and the basis of our kind of alpha application. So using those recommendations from Discovery, the project team is going to start off by looking at the current business practices and the bottlenecks that we face within that, and then start analysing the suitability of digital solutions to try and affect those in a positive way. We then want to assess those digital solutions alongside assessing the bottlenecks for their suitability for those digital solutions, and whether they're going to actually address the supply chain risks that they're going to do, and whether there's going to be any unintended consequences of doing that. At that point, we're going to end up having a build or kind of buy decision once we understand what smart tools are currently available in the market, and then go back around that curve again of understanding the effects of any chosen tool on the ancillary processes and building a business case around that, which would add a basis for potentially going into beta if we find something that's appropriate. And that all together pulls together with this theme for our alpha, which is going to be, can the digital tools provide solutions and improvements to our current procurement processes? Thank you. So on to questions if there are any.
Great, so we do have a question here. What is the backup plan if hydrogen embrittlement problems limit the life of girth welded steel significantly?
Helen, I think you're on mute if you're answering that question.
Sorry, I think I must have hit my spacebar by mistake when I was moving things over. Yes, thanks, Jeremy. So yeah, as part of looking at transferring the network into a hydrogen network, we're undergoing a huge materials testing program. That takes the standalone kind of hydrogen testing, looking at permeation testing, fatigue testing, flange testing, leak testing, all of that sort of thing. And that's done pipe, but also on welded sections. So we're doing that. We've got the work going on at Future Grid as well, which is our hydrogen test facility up in Cumbria, which is a demonstration site, looking at how repurposed assets, included welded pipe, react to blended and 100% hydrogen. And we've also got a number of NIA innovation projects looking at materials in the network and coating technologies and that sort of thing.
Wonderful. I think that is the end of the questions. If there's no others coming through, we're flying through these presentations. Thank you for that. We'll leave that Q&A open for a little bit longer if any questions come to mind. But with that, we will move ahead to our next presentation. Dynamic networks. Over to you.
Thank you very much. Good afternoon. Welcome to Dynamic Networks. I'm Ross Bibby, I'm project manager at SSEN Distribution. Today I'm going to be joined by Denver Runley and Charlotte Flowerdew from E.ON and David Wells from Baringa. Next slide, please. What this project's looking at is solving a problem that we currently have and expect to see more of in the near future. And that's large numbers of connections gobbling up the available capacity leading to constraints on the distribution system and the transmission system, meaning that it's difficult for other customers to connect, or at least they're facing very long lead times. And in the west of London, some customers have been connected, offered connection dates of 2037. So this map you can see here shows some of the problem in the west of London. This came from a report published by the GLA. Those red areas are primary substations that are already at or above 100% of capacity, with others coming in behind. So what we're proposing to do is to find an interim solution to connect residential properties. This is a solution just for residential. The GLA have warned that electricity capacity is likely to be a big blocker to housing development connection in the near future. What we're proposing to do is to install a load management system at a secondary substation that will communicate with low carbon technology devices in the homes, like heat pumps and EV chargers, and will manage the peak demand of those devices to allow us to then challenge the planning assumptions, the demand assumptions used in connections planning, to in effect connect a larger number of properties in a particular capacity than we would otherwise be able to if we use traditional planning assumptions. Next slide, please. So this discovery project had three aims, really. That was to ensure that the project was feasible from a technical, commercial and regulatory point of view, to make sure that we had stakeholder interest and that there was a positive benefits case. We have achieved all of those. There are no blockers to the feasibility that we've discovered. We've got interest from developers and from local authorities. And as you'll see later, we have a positive benefits case in terms of the CBA. From the work that we've done assessing the residential demand, we believe that we can reduce the demand assumptions in the design process, with very positive feedback from developers, Lend-Lease in particular, and the GLA. We did initially think that this was going to be quite difficult from a contractual point of view, but for connections in a constrained area, the new G100 standard, which sets out the technical requirements for customer import and export limitations, mandates that there is a control system like this put in place. So while we'll still need to do just as much consumer engagement, it's a mandated situation rather than a contractual one. And currently we're operating in a kind of regulatory grey area, which seems about right for an innovation project. There's nothing saying that we can't install this kind of solution, but there's nothing addressing it specifically. Next slide, please.
Thanks, Ross. So part of the journey in the discovery phase was understanding the customer needs on the project, particularly the key stakeholders. And we've put those into these categories here. So on the left, we've got the transmission system being the kind of 2037 reinforcement timescales that Ross mentioned. The distribution network itself, where the customers are connecting, the housing developers. So in the discovery phase, we concentrated on the new housing use case, with retrofit to be explored in alpha, as long as development on the new housing, and the domestic customer themselves who will be purchasing those households. And we can see that there's conflicting needs. So on the left, we've got system security as a big impact, and making sure that there's enough capacity on the network to connect new connections, new demand connections. But on the right, we've got pressurized timescales, customers wanting to connect and have more option and more opportunity to connect onto the network, have that housing available and be able to then purchase and live in those houses. And we think that the dynamics network solution that we've been investigating can address both the needs of the customer and the housing developer, whilst also making sure that we're maintaining system security on the network. and we'll look at that in more detail into the technical slides that follow. Next slide, please.
So our solution dynamically manages the loads of low carbon technologies within groups of homes supplied by a single secondary substation. This is carried out by monitoring the total load at the substation in near real time, and only when necessary, sending signals via a local secure broadband power line communication network to home gateways, which in turn relay commands to reduce consumption of heat pumps and/or EV chargers in those homes. Through dynamically managing these loads on the LV connections, we're then able to reduce the corresponding ADMDs, after diversity maximum demand figures, as we prevent coincidental loads of LCTs from creating a peak load condition in excess of the constrained capacity at the substation supplying those homes. It's really important to stress that steering of the LCTs is not anticipated to be a routine occurrence, but rather acting as an insurance policy to maintain continuity of supply if and when the local network comes under pressure during disadvantageous and infrequent conditions. Next slide, please.
So here we've got the individual work packs from the project that we undertook. There was a seventh one, which is a project management one, but didn't really seem pertinent to this. So the residential demand assessment, that's what we were talking about, with looking at the planning assumptions that are currently used in our connections process, and then how we can challenge them. We're now looking at a managed setup rather than what we currently do. We've developed a process for identifying viable trial sites by looking at how constrained primary substations are, and therefore those which are viable for this solution. There was a review of the regulatory and commercial landscape, and we have a number of commercial models now, and we understand the regulatory framework we need to work around. We've engaged with, as I said before, housing developers and local authorities on the stakeholder engagement front. We've also used existing literature on innovation projects that managed customers' demand and gained some insights from the customer point of view on that. We've got the high level architecture, which is very similar to which Den was just covered, on how we will communicate from the load management system to the homes. And we've got a CBA that I think we're going to come on to next. Next slide, please.
In the discovery phase, we concentrated on two kind of high-level CBAs, a societal return on investment and a developer return on investment. This is because the use case that we were focusing on in the development phase was a developer-funded solution. We're looking to explore more of the market options that we've identified further in Alpha. On this, on the slide here, we can see the societal return on investment, which is a high-level societal return on investment based on factors such as employment, kind of local authority funding, and local community funding. The project itself doesn't generate funding that wouldn't have existed. The factor here is that we are bringing forwards benefits that would have otherwise occurred much later in time. So we can see here that the transmission use case and the 2037 timescales, we've got very large benefits where we're looking at circa 10 years earlier connections than the counterfactual. It's also important to note that on the distribution use cases, we also see benefits across all the different use cases that we've tested, and bring those connections forward by a couple of years has a positive impact on the societal return on investment in the West London area. Next slide, please. Our thinking has evolved on the project in discovery from when we set out at the outset and our assumptions at the outset. We just wanted to highlight a few key areas in that is done so here. So going from the top, when we set out, we'd originally focused on the transmission use case and the 2037 reinforcement timescales, these being significant on the network, But as we've developed through the project, we've understood that actually there is a large implication on the distribution network behind reinforcement timescales on EHV and primary substations for secondary connections that we can also get benefit from. So going forwards into the alpha stage, we're looking at both the transmission and the distribution use cases across the project. The connection queue and trial site analysis, originally when we set out, we had looked at separating the new housing development scenario for trial site analysis and the retrofit. Going through the project and understanding more the opportunities there, we see that there's an opportunity to link the two and an opportunity to look at the capacity that's created in coordination with the retrofit use case and the new housing use case, coordinating that approach and making sure that we take both into account as we develop through the alpha. Originally, we'd focused only on the DNO as the owner of the network and the IDNO solely as a customer. We've understood through the regulatory and advisory work that the IDNO is much more of a complicated story than we'd originally thought out. As well as customer, they've got changing needs on them from changes in the access SCR and other that we are looking to further explore in alpha and fully define that commercial model. The load management scheme itself, we had some assumptions in the outset that there might be some voluntary or optional aspects to this, similar to a flexibility market, for example. But understanding throughout the project that in order for this to work, this needs to be a mandatory agreement in place in perpetuity until the reinforcement is complete. So in that case, any houses that are purchased which are underneath this load management scheme would be mandatory connected into the load management scheme. And finally, we looked at the benefits only up until the point of reinforcement. So the assets or any hardware being removed at reinforcement and decommissioned. But we've identified opportunities as we've been going through discovery that there might be opportunities to leave hardware in place or systems in place for customer benefit in the future, potentially opting into future customer load schemes or using the assets for alternative methods. We'd like to explore these further in the alpha stages. Next slide, please.
To alpha phase and reflect on the work we've completed in discovery, we recognise that stakeholder engagement, as David and Ross has already touched on, will continue to be a critical factor of our project, ensuring we continue to develop a fit-for-purpose dynamic load management solution that meets the needs of our varied stakeholder base and end consumers. So with that in mind, we expect to continue that engagement with ESO and NGET, particularly to understand that industry perspective at a transmission network level. We'll also continue to drive that engagement with the IDNO customer base, recognising we've done less engagement in that space during discovery as our understandings changed, again, as David's touched on. We'll continue to build on the validation and support we already have in place from a number of developers and the Greater London Authority, continuing to use them as critical friends to stress test our benefits case, our regulatory framework, to ensure that we continue to bear that in mind, particularly as we start to go onto that trial site identification as well. And we expect at that point to be needing to bring in additional developer stakeholders to the project. I think what's also key is through that discovery exploration, we've scoped an initial set of parameters focused on understanding that end consumer need. So the customer will move into these homes under that dynamic load management solution and understand through a level of consumer research in alpha, customer needs and their acceptance of this solution. And that really will shape our research process going forward, particularly around any differences of use cases for customers within new build homes or retrofit as well.
From a technical point of view, we'd only really considered a fairly simple network arrangement where numbers of houses were all connected to a single secondary substation, and it was a straight line between the load management system and the customers' homes. For alpha, we need to start thinking about how this system will work under fault conditions when the network is reconfigured and supplies are coming from different directions. We also, having now identified a number of commercial models. We need to start refining them. We need to start thinking about who's going to own the kit, who's going to be responsible if something goes wrong. All these kind of aspects need more work on them. We need to start looking as well at the social return on investment, the factors like improved quality of life from moving to a new home, from having better air quality, access to low carbon technology, that sort of thing. And we need to understand the retrofit trial site analysis and connections process in more detail. Next slide, please. So, as you probably guessed, we're planning on applying for Alpha. We think we've got a strong project here with them that we want to explore in more detail. And the purpose of the Alpha project will be to really bring us to a point where we can communicate, we have the full communication pathway between the load management system and the endpoint devices in customers' homes. We understand exactly which commercial business cases we're going to use. We've engaged with Ofgem from a regulatory point of view and understand whether or not we'll need a regulatory sandbox to undertake trials. We'll have a short list of trial sites for the new build use case, and we'll engage with the developers on those sites and be pretty close to being able to implement a live trial. And we'll have a longer list of potential sites for retrofit that we will refine throughout beta and implement later on in beta. We're also going to have, as Charlotte said, a substantial stakeholder engagement as part of Alpha to really allow us to design a proposal that meets the requirements of all the stakeholders and can actually deliver real benefit. That's everything. Thank you very much.
I'm just having a look at the Q&A. I don't think we have any questions. Leave it a couple of moments. If there's any that anyone wants to put in. No, okay. Well, we're now moving to a 15-minute break. And we will be back with you in 15 minutes. Thanks all. Do we have everyone back? Yeah. Do we have UKPN on to give Connectrolyser?
Yeah, I'm here with Mark.
Perfect.
Excellent. Good afternoon, everyone. I hope you had a good break. My name is Fiona Mitchell. I am a project that works, and I'll be presenting Chantal for our SIFT project Connectrolyser with Mark Turner from Hydrogenous, which I see on the front page I've actually spelled wrong. So my apologies, Mark. You'll hear from me more a bit later, but I'm going to hand it over to Mark to introduce himself and lead us through the first half of this presentation.
Thanks, Rona. So my name is Mark Turner from Hydrogenous. Just to briefly introduce Hydrogenous, just to contextualize us. So we're an organization, we're very much focused on developing projects to bring hydrogen to industrial, commercial and transport users. So we're seeking to identify those customers that have demand and bring those projects to fruition through establishing hydrogen production facilities. So I'm just going to talk a little bit about the problem, the benefits, and then some of the work we've done before I hand back to Rona. So if we may have the first slide, please. So in terms of the problem, so hopefully the graphic in the middle of the picture is fairly self-explanatory, but just to explain, so what we're particularly looking at here is a sort of typical hydrogen ecosystem of the future. So at the center will be electrolysers. Those electrolysers will be fed with a combination of power from the distribution network, but also behind the meter renewables. In this case, on the picture we've shown solar. The hydrogen that is produced will go to industry, either directly or in a compressed form of moved off site after being stored. And in the future, we're also likely to see hydrogen converted back to power and put back into the grid at times it is beneficial. Now, this is very much the future, and the industry is very much right now focused on the production of hydrogen, storing it for end use. The problem that we've been particularly been looking at collectively is the challenge of how do you connect essentially 5 gigawatts of electrolysers by 2030. This is government commitment, and actually if you project forward to 2050, that could be anything up to 8 gigawatts just connected on the electricity distribution network around the country. There will be a range of electrolysers that are connected in terms of their size. There will clearly be some very big electrolysers, big clusters, but we believe strongly that we're going to see a lot of, let's call them medium-sized electrolysers around the country that may be in the region of 10 or so megawatts, fairly close to end use, because we all know of the challenges of transporting hydrogen around the country. So 10, 20, 30 megawatts may be typical. And obviously that requires an electricity connection. If everybody tries to connect using the traditional firm connection, which is where I guess organisations like us and others would particularly concentrate, because we want to maximise the utilisation of the assets that we deploy and produce as much hydrogen as we can. This will clearly add pressure onto an already stressed distribution network. It'll bring higher costs and cause longer lead times as the network needs to be reinforced to meet these firm connections. So this project is very much focused on can electrolysers be served with a more flexible type of connection and unlock additional capacity that might be residual in the electricity network. So just moving to the next slide, if we may. We thought perhaps worth just starting with the benefits. I mean, the real prize that everybody is chasing here, particularly from a customer perspective, is the avoidance of reinforcement of the network by stopping lots of electrolysers coming onto the system that simply add to the peak supply demand in the future. Now, our partners, Imperial Consultants from Imperial College, have done some fantastic modelling work for us all during this discovery phase. And their modelling says that nationally, we could be talking about up to 30 billion in distribution network reinforcement costs by 2050 that could be incurred if electrolysers all add to peak capacity on the network. And if we can put flexible ways of working in place for electrolysers, much of that could be avoided. Now, that's clearly a very big number, and that's the top end. But even if a small percentage of that is achievable, that is a significant amount of money that is avoided or deferred for customers, because it is customers that will bear the cost of this upstream reinforcement in the distribution network. So that's the big prize, I think, for the hydrogen community, who is clearly trying to bring hydrogen into the economy to support decarbonisation. It's an imperative, and if we can connect electrolysers and produce hydrogen faster, then nationally everyone benefits from the decarbonisation that comes with that. So headlines, those are the benefits. Just telling you a little bit more about the work that we've done through discovery. So if we move to the next slide, please. The project is very much organised into 4 core work streams, with a 5th one, which is around project management. You'll see the partners and parties involved on the screen. So a lot of work has been done in terms of modelling hydrogen electricity demand. Now, not only have we been looking at what might be happening nationally, but this project is very much also grounded in the practicality of a real project that is emerging in central East Anglia. So we can have all that reality as we look at the work that's going on. So detailed work has been done on modelling hydrogen production requirements for that very specific project, which is around 8 to 10 megawatts in size. Network assessments have been done, both looking nationally but also at the local implications for that particular project, and looking at the ability for the connection to be flexible and smart in terms of supporting those electrolysers. And obviously that is all then culminated in a high-level business case. Just to keep going, if we may, next slide. So lots of learning has come out of this. I'll just pick 1 or 2 bits from this slide. The first thing I would stress is what is clear from looking at a local requirement is that hydrogen demand can be very peaky, and it is unpredictable, particularly in the world of industry, transport, where demand is not always clear. So when we talk about flexibility of electricity connections, it's really important that we have the right storage in place for hydrogen. So if the electrolysers aren't producing, there's enough storage to meet those demands. In terms of cost, so I mentioned the overall benefits nationally and the size of that prize. If we just look at this real practical example, in an unconstrained world, in this particular example, a network connection was estimated to cost a little bit over 20 million for a traditional firm connection. If that connection could be flexible, then we're talking somewhere nearer 13 million. So quite a significant cost saving here, in particular for the hydrogen developer. And also with that comes the ability to bring those electrolysers online faster to deliver decarbonisation. UK Power Networks did some work looking at how do their flexibility products and offerings support this. What was good was to note that those products are available and there is a good fit. So there's a lot of confidence that the UK Power Networks connections can support the kind of flexibility that hydrogen producers would be looking for. And the key in this is also then making sure that those hydrogen producers can take best advantage of flexibility that the power networks can provide. So I think that's the sort of the main benefits, and clearly there are other advantages to the electricity network by providing this flexibility in terms of having a flexible load that can be taken on or off. And indeed, when we think about the future of power going back into the network, ability to support security of supply in the distribution network. So that, I would say, is the sort of some of the key learnings. If I just go one slide further, I mentioned this is based on quite a lot of detailed modelling. So modelling has been looked at from a variety of aspects, so both national demand, local hydrogen demand, and impact on the local distribution network. So again, just to reinforce the great work that ICON has been done as a partner in this. It's all been done over quite a short period of time, and we'd be very hopeful that we can get support to move to alpha. More modelling will done and more refinement. So hopefully that has provided everybody with a sort of an overview of the benefits and what we've done. And I'll just pass back to Rona just to close out with a little bit more information.
Thank you, Mark. So kind of to take that and repeat it in a different way, some of the key questions that have come out from our analysis, when you look at, this is a slightly more simplified diagram than the one at the start, kind of for every piece of the hydrogen hub and the bits connecting or its links with the other networks, there are questions around how big should this piece of equipment be? How should we operate it? When should we operate it? Is it being operated constantly? Will you ramp down your electrolyzer when the price of electricity is high, or would you turn it off? If you're going to be doing that a lot, should you then invest in a larger size hydrogen storage facility? How will you get it to your customers, or transport and things? They need hydrogen at really high pressures. For some industrial applications, you can have it closer to atmospheric pressure, lower pressures. So there's a lot of things to think about going forward. And what we've increasingly been thinking about is that in a whole systems approach, it's hard to decide where you draw the line to try and optimize for everyone's benefit. So we look forward to doing more of this in the alpha phase and coming up with some answers to these important questions. Can I get the next slide, please? So through this journey, we actually met up with 5 other SIF projects to understand what they're doing, because there's quite a lot going on in the space discussing electrolysers and other things, looking at connections. We've heard about some earlier today. And we did not find any obvious opportunities to collaborate, but it's been really good to understand what other people are doing. And I think there's lots of different challenges to the rollout of green hydrogen production. And all together, I think we're going to move this industry forward. And even through the show and tells, I've even picked up other projects that we haven't yet met with, who I think would be worth talking to. So as we all move forward, we're doing more of that. Next slide, please. So just kind of talking to the problem itself, the PEM electrolysers offer a potential to exploit flexible electricity distribution connections to benefit the hydrogen producers as well as the distribution network. There's two main things here. One is that operating these types of electrolysers flexibly there's not a lot of information out there about how flexible that equipment is in terms of if it's ramping up and ramping down multiple times a day in response to signals from the network. I think it's unknown really what kind of impact that would have on the equipment long term. So that's something we want to look closer at in the next phase. And to make this actually work, there needs to be optimization control systems to bring it all together. And especially, I don't want to use the word machine learning, but sort of predictive control systems that are looking at weather forecasts and looking at historic electricity prices to help you decide best how to run the system. And there really are a lot of wider societal and customer benefits to a fully flexible hydrogen hub operation. So as Mark said, we're looking at a specific area in East Anglia where there are established hydrogen customers, people who would be interested in buying hydrogen. Yeah, looking to move forward. And last slide here. This sort of, we've got an emerging view of what the beta solution is. The alpha stage is a stepping stone to this, to do more design. But the center of it really is what we're calling the Connectrolyser, which is a behind the meter control system, which can integrate with the distribution network's DER management system, which is what's used to manage flexible and curtailment at the moment to perform those types of connections. So to understand or develop and demonstrate a control system, and then also looking at the flexibility in action of the PEM electrolysers, showing to really understand what the benefits are. And then third point there is looking at what enhancements may be required to DNO monitoring and control to exploit full value of this. And yeah, the aim is to put DNOs on the right foot in rapid and smooth deployment of electricity, because it's a big thing. And I know there's been, in some other projects, there's a view that there will be a lot connecting at the transmission level, but the forecasts also show there will likely be a lot at the distribution level. So we need to be ready as well to not put that back. And that is the last slide. So thank you very much. If we just, there you go. Those are our email addresses. If you have any questions that you don't want to raise in the Q&A today, or if you think there's an opportunity for our projects to learn from each other, you're very welcome. Thank you.
Thanks all. We do have a question here. What hydrogen storage capacity, pressure, volume, etc. do you envisage is needed for the hub, and have you looked at buried pipelines as a storage option?
Sorry, can you hear me?
Yeah, can hear you.
I don't have the numbers to hand on the hydrogen storage, but if you want to drop me some details after, I can dig those out. We haven't actually looked at buried pipelines for storage. We would be very interested in that. I'm not sure where the question is coming from, whether somebody's got a solution for that. We'd be very interested in that. The solutions that are really being considered at the moment are above ground storage, and indeed we are aware of another SIF that is looking at storing hydrogen effectively, chemically. So we will be considering that. But if you've got some details, we'd be very interested.
Perfect. I don't think we have any more questions, but like I said earlier, we will keep the Q&A open for a little bit in case any come to mind. We're running a little bit ahead of schedule, but I will move us on to our next presentation. And over to you.
Okay, good afternoon, everybody. I'm Chris Goodhand of Northern Power Grid, looking after the SIF portfolio. This project is artificial forecasting, about supporting the robust delivery of net zero, as we all are this afternoon. Can I have the next slide, please? And the next slide. There we go. Okay, well, we'll all recognise this. The world is becoming increasingly complex. We have many more asset types being attached to different places on our networks, and these are very different to what we have historically known. And it's not going to become any less complex as we go forward. So what we need to actually manage this over time is a more granular view of the network load. and an improved ability to forecast what is going to actually occur on the network. So we're going to need faster forecasts, shorter, near real-time sort of timescales, and certainly at much lower voltage levels down at the network. Currently, we have forecasts that are aggregated at quite high levels on the network that take quite a considerable time to put together, and they tend to be at reasonably medium planning horizons. But that is not going to do going forward, as we want to move to a distribution system operator and implement much more flexibility on the networks. So this project is artificial forecasting. It's aiming to use advanced analytics and diverse data sets to deliver much more dynamic forecasts that are the sort of thing that will be much better for us as we run the future networks that we are going to need to meet the low carbon future. With that, I shall hand over to Andrew, who shall tell you a lot more about how we've gone about delivering this.
Thank you, Chris. And if we move to the next slide, please. So firstly, I'm Andrew Glennie from faculty, and we develop and deploy custom AI tools in critical national infrastructure settings. And my role is to oversee their application to the energy networks. And I've been leading our contribution to this work with Chris and the MPG team. So two main forecasting challenges in this work. So the first of these is looking to develop granular forecasts of load at half-hourly intervals at primary substations. That's where extra high voltage is translated to high voltage. And that's with a view really to support procurement of flexibility. And that's given where most of the provider of these services are connected at ED2. The second item here is looking to demonstrate value from low voltage monitoring data, and that's developing forecasts at a weekly and monthly level to assess, the impact of new connections and potentially support network planning decisions. So if we move to the next slide, please. In terms of what we did at Discovery, broadly 3 work packages with a real focus on the AI discovery component. And that first work stream to the left there was formed firstly of user research. And like in any kind of AI and software discovery phase, really trying to understand MPG's objective, develop the scope of work in more detail, and actually understand how we can influence business decision making. Secondly, moving on to ingesting an initial data sample for both scope items, understanding how the data that's available can actually inform a solution that addresses this problem statement, and then lead to actually the development of a series of technical approaches and AI methods that we could use to forecast most effectively. My colleague Julia will run you through those later in the presentation. Lastly, there around benefits, once we've understood the problem statement and the data and methods that could address it, actually forming, okay, well, what are the benefits that fall out of a potential solution for customers? The second 2 work packages there, very much forward-looking, so around alpha planning, developing a coherent strategy to develop a solution, a proof of concept solution at alpha, and then in terms of sharing the learnings within work package 3, and that also involves some validation components with our partners at UKPN to understand the applicability of what we've been doing to other DNOs. If we move to the next slide, please. So we'll touch a little bit for the next few minutes on the findings from this work. So starting with user needs, we held a number of user research sessions throughout the project to assess what MPG are currently doing, the capability desired, and the solution characteristics that need to fall out of this. And importantly, like the business application of these tools. So for example, how a forecasting solution can be integrated into procuring flexibility. And I think the takeaway from this phase of work is that both of the scope items I set out at the start are really developing new capability for MPG. So for example, in procuring these market-based solutions versus reinforcement in the first instance, and secondly, in utilizing low network data in terms of low voltage monitoring. And these are directly customer-facing benefits that result in terms of avoiding reinforcement expenditure, for example. Secondly, I guess another learning around the technical implementation of feasibility, very much around how MPG collect, store, process the data used for this type of work, and that's really going to help us in forming a solution for the alpha phase. If we move to the next slide, please. So what did this mean? So as I mentioned at the start, the scope of this project has evolved as we've got to know different user needs and how it can be applied across the business. So having come in with a fairly high level scope, this was then refined into and disaggregated into a real specific set of challenges. So this not only confirmed the timescales that we're looking to address through a solution, these half-hourly intervals for the first scope item, for example, but also the target variables of these forecasting solutions. And as you'll see, this first scope item there disaggregated into forecasts of gross demand and net demand. And this is really important because net demand, which is formed of gross and also the generation connected at distribution level, so far, a lot of work to date has treated this as a time series problem, namely looking at past values and extrapolating into the future. But as this distribution connected generation increases over time, those approaches are going to be increasingly volatile, increasingly inaccurate, and we need to understand the components of that net demand to develop an appropriate forecast. And Julia will take you through a couple of methods we've identified by which we can do this. So that's a particularly important disaggregation we've learned throughout the project. And speaking of which, I'll hand over to Julia to take you through some of the technical learnings.
Thanks, Andrew. I'm Julia, data scientist at faculty, and I will guide you through the main data discoveries and the forecasting models that we suggest. First, if we look at the data for the different scope items, we see very different patterns, which made us think that it was a good approach to consider different models for each scope. In more detail, we found that gross active power at the high voltage level on the left of the slide here is a time series with regular patterns. And if we plot the data from 1 week against the previous week, we see it is highly autocorrelated. However, at this same level, when we look at the customer expert, which combined with gross will roll up into the net forecast, it shows that it's not temporal data, it has an irregular pattern, and it's not autocorrelated. Then moving on to scope 2 at the low voltage level, we found that there is some regularity in the active power data and its autocorrelation. So with this, if we move to the next slide, please. So since as seen, the data for each scope is different, they might require different approaches. Because of this, for each item, we have a version 0 model that should be relatively straightforward to implement to get something quickly up and running. And then we pick 2 other models that represent a range of pros and cons around, for example, the needed assumptions or their explainability. Regarding the models for scope 1.1, that should be our easy model as the data is highly autocorrelated. So a standard time series model with some exogenous factors would be appropriate. And after that, we consider 2 approaches. First, the Bayesian linear regression, which can handle probabilistic forecasts, and then Prophet that supports some nonlinear trends and more exogenous factors. Then in scope 1.2, the data had a non-temporal pattern. So the focus here, we think that should be on extra data collection, especially for the non-weather related expert. Alongside though, we are proposing machine learning with tree-based methods for its forecast. And then if we move on to the scope 2, we saw that the data shows some regularity over time. So sequential data methods would be fitting, such as LSTMs or temporal convolutional neural networks, which are deep learning architectures designed for sequential data, but with some flexibility and exogenous factors. As another technique here, we are considering hierarchical approaches because the data can be grouped based on low profile or the connected customers. So now to talk about the benefits from this project, I will hand over to Andrew.
Thanks, Julia. If we move to the next slide, please. So yes, on benefits, the last part of that first work package. So as standard within these types of assessments, first ask here is really to define the channels by which benefits can come across from our solution. If we start with the middle there, so in the first instance, I mean, a better forecast can lead to more efficient procurement of flexibility, bring that closer to the time of use, and avoid reinforcement spend through procurement of these market-based solutions. Related to that, if we can understand the load profiles at different substations, and that's both talking at HV and LV, we can target maintenance more effectively, and also potentially lead to a reduction in the risk of outages. Internally for DNOs and an MPG, there's also this point around the complexity of existing methods and how difficult it would be and labor intensive it would be to roll out these methods to this particular challenge and try and scale across the forecasting required. So by developing this solution, there's potential efficiencies in terms of better allocation of the expertise within the DNO. So those are the four main things we've quantified at Discovery, but that's not all the potential channels that this project could deliver. So Alpha would look to expand further on what we've been able to do in the 10 weeks or so at Discovery. So on one hand, an additional channel is the facilitation of new connections to the distribution network and those connections of green assets that can really support that net zero agenda. And if we can put some sort of carbon valuation on those new connections that are being facilitated. Secondly, and one of the reasons we're looking to bring in flexibility partners for the Alpha phase is understanding how we can engage with these flex providers to really understand how we can most effectively procure their services, and in doing so, understand the scope for new revenues for these providers of network services. So looking to elaborate a little more in the next phase of work. And there's initial assessment there as to the MPV that's still being refined ahead of the application for Alpha. And if we move to the next and final section, so a bit of a look ahead into what we can expect for Alpha, which we'll be applying for in the next week or so. So what's the objective here? So in Alpha in general, when it comes to AI, we are looking to test and train the methods that Julia set out, understand the scope of value that they could bring, and ultimately appropriate methods to deploy. But just as important is actually how you can integrate those into business decision making. So integrate with, say, flexibility procurement. And this integration is a real key part of making sure that we don't just have a predictive model that is standalone, but is actually used by the forecasting team and flexibility procurement teams. So you'll see that a lot of our plan here is dedicated towards this technical approach and technical aspects, both in terms of POC, proof of concept model development, but also that integration phase within that block into decision making. And that's taking up a significant portion of the 6-month period. You also see there that there are components to do with benchmarking our approach, and that's both from a network partner perspective in terms of confirming the applicability of these methods to other DNOs, but also from flex providers. And as I mentioned, we're looking to bring in expertise in this regard to understand how we can best engage and use these forecasts to procure flexibility. And that's both an issue at ED2 with flexibility at HV, but leading into ED3 with flexibility at LV in future. The last couple of work streams there are very much around iterating and refining the business case as we learn more about the solution and how it can be implemented. And the last one there around making sure we can integrate successfully into the organization from an information security perspective. So yeah, fully looking to apply for Alpha, really enthusiastic about this project and the capability it can bring to MPG. I hope you found this interesting and welcome any questions or interest in the work. So thank you very much for your time.
Great, so I think we do have a question here. AI doesn't have much regulation at this point. What kind of data protection measures are you considering as part of the project?
It's a fair question. I think we'll start off by saying a lot of the data that we've collected to date is publicly available on MPG's open data portal. So there's an open status of that information. Where data protection really comes into it is when we're looking to, say, forecast customer side generation, for example, where you might be able to identify owners of those assets. So that will be where we need to be very careful with privacy considerations. But for the most part, the load information is relatively safe in terms of these data privacy and protections.
Great. Well, I think that was all the questions for this one. Thanks for your presentation. We will now be moving on to our next presentation.
Good afternoon. Hello, I'm Jonathan Powell. I'm going to be starting off the presentation about React. Next slide, please. Okay, I'm an innovation project manager at SSEN Transmission. And before we proceeding any further, I'll just name the partners and say a little bit about them. So we've got MapStand, who've been building up and integrating spatial data sets alongside reviewing H2 developments in Northern Scotland as part of the work through the discovery phase. All sites, so they take these data sets built by MapStand and build visual tools that can provide energy infrastructure insight and help scope project requirements and drive decisions within the business. And last by no means least, we have Icebreaker One, who led the stakeholder engagement activities, resulting in the use case and help to access the various data streams and navigate our way through open data. So in the next slide, please. So the problem, in the next 25 years or so, the UK electricity demand is set to double if we were to achieve the net zero targets. One of the growing problems is ensuring that each development is located in the best possible location on the network as it becomes increasingly congested. Currently, the process of reviewing connections requests is carried out individually in isolation, and there is limited opportunity to develop more innovative solutions. And moreover, the current process does not provide a dynamic view of the potential impact on the network of the proposed connection. So in summary, there is a growing demand for energy, which is likely to have a large impact on how efficiently the network operates looking into the future. Next slide, please.
Hi, good afternoon. My name is Tony Griffiths. I work for All Sites. So I just start with saying that REACT stands for Rapid Evaluation Areal Connection Tool. And as an overview of the REACT project, the objectives really are to provide a geographical planning tool, to provide a dynamic view of power flows and future connections. The benefits of this really are to provide developers with alternate project network locations, to help reduce the burden on pre-application time and resources, both for developers and transmission owners, and also to reduce CO2 emissions by using existing networks where possible and avoid reinforcements. And during the discovery phase, as the use case, we're really focused on electrolytic hydrogen connections in the north of Scotland. I've got a couple of pictures there. I just say that the top one represents our starting point for an existing tool that we're looking to build this additional functionality onto. And the bottom picture there is really to show one possibility of how we can look to visualize the connections between queued projects and designated substations. Next slide, please.
Hi, I'm Zoe Swiderski from Icebreaker One, and we were responsible for the user needs analysis and stakeholder engagement for this project. So for the user needs research, we undertook interviews with over 20 stakeholders so that we could discuss the process and challenges for connection applications and identify the necessary data sets for this, both those already available and those not yet available. From this and our desk research, we came up with the list of problem statements that you see on the screen there. So we then brought together key stakeholders from different departments within SSENT, key figures in the energy sector, and obviously our project partners. And together we discussed the problem statements and we ranked them in order of perceived priority. As you see highlighted in strong green, the problem statement number 4 was voted as the highest priority. So it's hard for a transmission owner to determine the future capacity of the network because they're unsure which potential developments will connect and when. This top ranking one was closely followed by numbers 7 and 8 in light green below it, concerning lack of knowledge for the best location for the hydrogen electrolysis development and the needed data being held in silos. Next slide, please. So we took these top ranking barriers, if you like, and throughout our research process, digging into these, 2 key themes stood out. Firstly, from the example we explored in the north of Scotland, we saw that there's a lack of seamless data flow in the application and consent process, and this can lead to a lot of wasted time and resources. And secondly, we identified that there's a need for innovative solutions to reduce friction and improve the process. So we came up with a list of recommendations to address these 2 key themes based on the example of SSENT, but they should also be pertinent to other transmission owners. So I won't read them all, but just pick one from each. So recommendation to reduce friction includes access to more extensive and relevant data, and Francis will talk a little bit more about data opportunities in a moment. And then a recommendation to promote further innovation could include creating a digital twin of the power system with existing data rather than continuously waiting for the perfect data to be available. So next slide, please.
Hi, I'm Francis from MapStand, and our main role in this project so far was working on the spatial data sets and evaluating the possibilities of these. In looking at the sort of opportunities to address the problems that have just been mentioned, one of the key roles that ourselves and Icebreaker 1 have been working on is the identification of the key data sets that we would need for this project and for moving on into the next phase. One of the key things that was identified very early on was that there was no real data standards across these data sets within the specific area we're looking at, but then as you move out to the whole UK and the different companies involved in both the transmission and the distribution system. We also, as part of this, have identified a series of data sets that are not currently in the public domain. These are the data sets that are kept in silos or are part of internal processes within the transmission operators that are not published as part of the open data standards. And these are critical in developing some of the potential tools that we would need to describe power flow and also connection queues effectively in a way that developers would require. As part of this, we looked at the workload and opportunities of standardization, normalization across these data sets and potential data integration workflows that we would need to build. The sort of workflow on the right of the slide sort of highlights some of these key data sets and areas. So in the restricted data area, we have a lot of the sort of power flow model data that is currently not available in the public domain. That relates, for instance, to some of the data that is in the electricity 10-year statement, but model runs that are a different frequency or seasons that give us the ability to build new models. Early connection queue information. This is obviously very, very difficult data to evaluate. There are big concerns about confidentiality in early projects. Especially where the transmission operator or other stakeholders are having these early sensitive and confidential conversations. But some of this data is actually very important in wider evaluation of the grid and the potential sort of opportunities that are available. And another key area has been the availability of substations and the status of them. Is there capacity to expand the substations or not? Is there currently availability there for a connection? And these are things that developers are not able to find good information on at the moment. Within the open data sphere, the data integration that we're looking at incorporates data from the tech register, planning data, embedded capacity registers, and all of the other data registers that provide a view of connected or non-connected capacity or early projects in planning or in environmental planning stages. A lot of these data sets are not standardized, they don't join together, and they're also non-spatial. And this is a key component of the tool that we're looking at, where there's the spatial distribution of these projects in relationship to other key spatial constraints, such as water or the offtake of the fuel. In the use case we looked at hydrogen, what is that business model? How does it work? How does it get to market? That really predicts the viability of these projects. Next slide.
So in approaching the problem, we recognized that some of these electrolytic hydrogen developments that require transmission connections, they're going to be coming thick and fast in the future. So we identified already that in planning and development, there's around 7 gigawatts worth of electrolytic hydrogen in this area, above 10 megawatts each. So that's across 18 developments. So that fits quite well with Scottish policy, that has an ambition for about 5 gigawatts by 2030. But if we look beyond that, by 2045, they're looking for an ambition of 25 gigawatts. So we know that the number of developments in the queue will only increase, and they're all different. We're seeing that developers are submitting applications without very much knowledge of network constraints. And in approaching the problem, we're looking to address and assist frustrations that we knew about with that pre-application process. So this is focusing broadly on understanding uncertainty and sensitivity at that end of the development cycle, rather than precision. And really, we're trying to help stakeholders on both sides to really understand this by capitalizing on modern emerging visualization techniques to help decisions. There's a couple of pictures on there on the right. So these are just examples of some of the analytic tools and dashboards that we've been using really to understand and analyze what current data we have is telling us about the future connection queue. Next slide, please.
Good afternoon, I'm Roddy Wilson. I'm a network planner for SSEN transmission. So in Discovery, we've seen two main benefits for the tool: streamlining the early stages of application and helping to get the most out of the existing and planned network infrastructure. By providing a more informed starting point, we think the tool will help the pre-application meetings between the key parties, which are typically the developer, the network company in the area of connection, and the system operator. And with this, especially with the spatial tool, developers will have more information on which to base their application. And this in turn, we think, can increase the chance of an application turning into a connection at the end of the day, and reduce the great volume of connection assessments that are carried out presently on schemes that never proceed to connection. And that issue is taking a lot of transmission owner and system operator resource. So the tool, that, as has been mentioned, will indicate the things like the impact that the connection queue is expected to have on the network, and this will allow the developer to make choices about favorable connection locations from a network point of view, alongside the other factors that impinge on their project decision-making process as to where to locate. So from a network point of view, for example, this will indicate where capacity is available and lead to the expectation that that will deliver faster connections, and connections at points that are favorable to the network in the terms of reducing operating costs. So I'm just going to pass back to Tony to talk about some evolution of the project. Thank you.
Yeah, thank you. So as we went through the discovery phase, we developed, I think, a much clearer understanding of some of the frustrations and issues that particularly developers are having at this scale during the pre-application process. And this really led us to focus on identifying and sharing, early insights on constraints for these projects, which may not all be power transmission related. So, for example, for some electrolytic hydrogen developments, they may be constrained by water or some other factors. So really the emphasis is on broad insights, whole energy, being able to see power, but also gas networks, water, land use, etc., getting the full picture. We also became much clearer on what we wanted to do with aspects around modeling power flows. So rather than trying to replicate generating new power flow models, we decided that we wanted to make the best use of existing power flow runs that have already been generated and already supplied as part of the ETIS 2022. From those runs, it becomes quite easy to create seasonal sensitivities, which we can then visualize. We've also talked about potential opportunity to use the Pi Historian data to calibrate things like intraday or seasonal variations and statistical variations, really to inform the shape of operation of these circuits. We also came to I think understand a lot more about the existing SSEN power flow digitalization program, which is ongoing over the next few years, and the way that we now understand the REACT project will hopefully support and strengthen that program in the coming years. A couple of pictures there on the right. So the top picture again is the starting point for what we have for visualizing the kind of whole energy, so power, gas networks, land use, topography, etc. And then the bottom picture, this shows these are the power flows within the circuits as they're currently presented in one of the appendices for the ETIS 2020. So there's already starting points on which we can connect this together and re-visualize in a different way. Next slide, please.
So this work is very much part of a drive to plan the network efficiently and in a coordinated manner and in a way which supports decarbonisation. And it's doing that the network's doing that by transmitting power from renewable sources. And the tool will help target connection locations for other developments which are necessary for decarbonisation of the energy system, such as hydrogen, which we've concentrated on during discovery, and in the future storage as well. And that would be alongside the other sources of renewable power. The tool is deployable for that. The spatial mapping enables resources and regional targets for net zero decarbonisation to be compared along with the parameters of the existing transmission network. And that will all help identify the most effective and rapid development pathway for the network. So outcomes for the future. I'm going to hand back to Jonathan for what's next. Thank you.
Thanks, Roddy. Yeah, so the work of discovery has certainly proven that there's a lot of benefit to taking this into an alpha application, which is what we plan on doing, and certainly in the near term. But we also felt that it would, because of the wider appeal of such a tool, not just to SSEN transmission, we felt it was helpful to broaden the partnership. So we've invited SGN and National Grid, who've agreed to join the alpha phase application, because they can provide, obviously SGN can provide gas network infrastructure information, National Grid obviously has a more, I suppose, more holistic approach across the UK network, you know, compared with ourselves. A few of the things that we've identified as key areas for the alpha phase is data accessibility and interoperability. You know, obviously, given there's a number of organisations and various disparate data sources, you know, that the accessibility is key as well, just because of you know, confidential data versus open data, as was discussed by Francis. In terms of the tool development, we're going to adopt an agile approach. So we've got a number of user group it kind of embedded in the partnership. So that'll be SGN, National Grid, and ourselves. And we're also going to talk to some developers who are going to on a more ad hoc basis through Alpha, where we can share the tool as it stands. They can run some tests, and then the tool can be refined through a number of iterations. And finally, on top of that, we're going to mature the CVA. We've already had I suppose, a preliminary look at the cost benefit analysis, and it's certainly a compelling case. There's benefits to be had on constraints, curtailment, and transmission network use of system charges, a reduction of those as a result of the tool. So that concludes our presentation. So we're happy to take any questions now, if there are any. Thank you.
Thanks for that. A question here, you mentioned engagement with local authorities and the impact of planning permissions. Will local authorities be involved in future phases of the project, or was this limited to discovery?
I mean, I can start this one off. Certainly we've got a work package within Alpha looking at a user group. So, I mean, within that is the networks, developers, but we're also, you know, acutely aware of public authorities and, you know, the impact it can have on them. So we've kept that work package quite, I suppose, general at this point in time, because, you know, we do want to get as many stakeholders and involvement, you know, as broad as we can. So, yeah.
If I could come in as well in addition to that. So I mentioned local net zero targets. I think that would be an area where engagement with local authorities could come in the future. We're very keen in the transmission field to develop our understanding of how GB overall net zero targets can be resolved down into local areas and local authority areas. This tool would present an opportunity to promote those discussions, those engagements with local authorities in a, you know, really quite a meaningful way.
Well, another one here. How are you addressing regulatory considerations through the project? Regulatory barriers are often cited as a barrier. I think too speedy connections. I think that's meant to have on the end of that.
I'll come in again. I mean, I think there are potential regulatory barriers around things like information sharing. So network companies can share information to a certain degree among each other. So we would, in subsequent phases, I think, look to explore that a bit more and the true barriers that's presenting. Other aspects are related to one thing, wanting to know what you might want to do, but we have to convince our regulator. If the answer's in network infrastructure development, we need to convince the regulator that it's well justified. So the tool offers opportunities to help that conversation.
I could maybe come in a little bit as well for both questions. Stakeholder outreach is still a huge part of our alpha application. So we will continue to reach as many, and it's the breadth of stakeholders, not just targeting in only on one group that they're happy and everyone else isn't. So that would include local authorities as well, but also the regulator. We would plan to run an advisory group, for example, and that would be open to the range of stakeholders. And we would encourage the regulator to join as an observer if they are unable to be actively participant, but just so they're at least aware of what's going on and what people are saying and where these barriers are coming up, so that they can at least have the knowledge, even if they're not actively able to participate at a given moment. So we do every possibility to get everybody involved.
Wonderful. Well, thanks for that. That does bring us to the end of our presentations. I believe that Chris wanted to just say a quick word of thanks, and she's put some links into the chat as well for our ideation workshops that are coming up.
Yeah, thanks, Ellen. I just wanted to say this is the last of our show and tells that we've been running. There's been 11 themed sessions over the last 2 weeks. It's been a huge amount of work for all of the 53 projects involved that have taken the time to put together excellent presentations. We've had 157 speakers across those 53 projects, which is absolutely phenomenal. We're so pleased and so proud of the research that's been done and the great ideas that are coming forward. And we can't wait to see some of these go through into the alpha and then into the beta phase and be really successful and really have that impact on the networks, on the future of net zero, on the energy consumer. So thank you all for your time. And thank you also to the 455 people who have registered to attend these events. I hope you've got a lot of information out of it. We've certainly enjoyed seeing the projects, and I hope you have too. You will get followed up by this with the recordings, and we've had some links already shared on the chats with regards to some upcoming webinars that we've got. We're running a whole series on an introduction to the SIF, and we've also got some ideation deep dives on sort of specific areas around cybersecurity and other things. So please do continue to get involved. I'll leave it over to you, Ellen, to wrap up. I know you've got a couple more slides, but thank you once again to everybody who has been involved in these sessions. It's been brilliant.
Thanks, Chris. Yeah, so just to flag these ideation sessions, and yeah, the participants are welcome to send through if they did have any questions that came to mind to myself. I'm happy to pass these on to the networks if they do come to mind. There is lots of ways to connect with us, so these are all flagged here on screen. But yeah, thank you once again for joining, and we hope to see you soon. And we're looking forward to these alpha applications. Thanks.